So in the first one, what is the domain? Put 0. I would agree. All real numbers, x cannot equal 0. Everybody agree on that one? Set 3x equals 0. 3x equals 0 solves out 3x equals 0. X equals 0 is the domain. But that means that x equals 0 is our vertical asymptote. Yep. So x equals 0 is our vertical asymptote. Okay. Now, yesterday, you should have watched a video in class that told you how to go out and find horizontal asymptotes. Okay. So we look at the degree of the top and we look at the degree of the bottom. So the degree of the top is what? 3. The degree of the bottom is 1. So that's big over small, right? So that's what in terms of on our cheat sheet. That's a none horizontal asymptote. Okay. Big over small, none. Small over big, y equals 0. Same, we look at the lead coefficients. Okay. Good to go on that. Domain on the next one. All real numbers with plus or minus 3?
No, not 3.
No, it's not. Okay, now let's think about that. All real numbers, but x cannot equal to what? Not a real number. Not a real number, right? It's imaginary, right? Okay. What's the domain here? It's just all real numbers. It's just all real numbers. Now, let's do some logic thinking here. Okay? Normally, we would set the denominator equal to 0, right? Okay? X squared plus 6 equals 0. Okay? And then we'd subtract 6. Negative 6 equals x squared. Square root. We get x equals plus or minus I squared root of 6. Okay? Right? But that's not real, isn't it? Okay? That takes those out. These are just all numbers. Another way of thinking, if I put a negative number, any negative number, and I square it, that's going to be positive, right? Plus 6 is going to make it be positive even more. Okay? If I put 0 into that denominator, 0 squared is 0, plus 6 is 6. If I put a positive number in there, square it, positive, add 6 to it, it's going to be even bigger. So the smallest value that this denominator could get would be 6, which is nowhere near 0. So it's all number. Okay? Which means, how many vertical asymptotes do we have? None. We don't have any because we have no restrictions in our domain. Horizontal asymptotes. Degree of the top. 2. Degree of the bottom. 2. So that's the same, right? So then I look at the lead coefficient. What's the lead coefficient on top? 2. What's the lead coefficient on the bottom? 1. 2 divided by 1 is 2. So this is y equals 2. Questions on that? Good stuff. I threw you a little curveball with that, just straight up all real numbers. Okay. So on these 3, find me all the asymptotes. Notice what the only thing I changed was the degree of the top. Find me all the asymptotes. once you found one vertical asymptote, you should find, or once you found vertical asymptotes for the first one, you should be able to find vertical asymptotes for all the rest of them. Because they're all the same, right? All the denominators are the same. Okay? So, are there any vertical asymptotes? Yay or nay? Okay. So if we said, we would say 3x squared plus 1 equals 0. So then that would be 3x squared equals negative 1. That would be x squared equals negative 1/3, right? And can we take the square root of negative 1/3? And it'd be real. Nope. So there's none throughout there. Okay? So on all of these, there is no vertical asymptote. Okay? So then we just got to look at horizontal asymptotes. First one, degree of the top. 1, degree of the bottom. 2. 0 is a number. Y equals 0 would be the horizontal asymptote. Middle one, degree of the top. 2, degree of the bottom. 2. So then they're the same, right? So we look at the lead coefficients. Lead coefficient to the top. 2, lead coefficient to the bottom. 3, so it's y equals 2/3. Degree of the top in the third one. 3, degree of the bottom. 2, none. That was a none because the top is bigger. Okay. Questions on that? Okay. So what I would like you to do is get out your supplemental note sheet, which it should already be out, but okay. So now we've got 3 more things that we need to find on it. So we're going to do steps 3, 4, and 7. I know it's kind of goofy, but trust me, you'll see. Okay? So step number 3 says we need to find the y-intercept. This is going to be where the function f of x crosses the y-axis. With any function, a line, a quadratic, a rational, a quartic, any function, how do we find the y-intercept? Plug in 0 for x, and we figure out what the result is. When we give the y-intercept, remember that the y-intercept is a point, and it is the point 0, comma, some number. It's not just 7. It's the point 0, comma 7. We're going to be in about 15 minutes, probably not even. The next slide, we're going to start graphing. Okay? By the way, fellas, there's graph paper over there. Okay? We're going to start graphing here momentarily. This is going to be your first point that you graph. Okay? because it's the easiest one to find. So that's the first one. Second point you're going to graph, or second points, you're going to actually, let me tap the brakes. How many y-intercepts can you have?
One.
You can only have one. Okay? Can you have none? Yeah. Because if your vertical asymptote is x equals 0, then you won't have one. Otherwise you'll have it. Okay? But the maximum you can have is 1. Okay? Next one is going to be find the x-intercept. Okay? Now, this is going to be where the function crosses the x-axis. This one's a little more challenging. Okay? So this is where the value of the function is 0. Rational functions are fractions, right? When is a fraction? And only when is a fraction equal to 0? When does a fraction equal 0? And it's the only time a fraction equals 0. It's a question you probably never even thought of. It's just 0. But if I have a fraction, when can that fraction be equal to 0? Denominator? Numerator? Which one? Top or bottom? It's going to be top or bottom. Top. When the top is 0. When the numerator is 0. That's the only time that a fraction can be equal to 0. Is if the numerator is 0. If the denominator is equal to 0, crazy things happen. So crazy that it's never happened before. But when the numerator is equal to 0, when the top is equal to 0, that's when the fraction then is equal to 0. So in order to solve for the x-intercepts, we are going to set the numerator equal to 0 and solve. So whatever the top is, you set it equal to 0. Solve it out. How many x-intercepts can we have? How many? Just one? Multiple? What does it depend on? Of the Hadley coefficient, the degree of the numerator. And the degree of the numerator tells you how many x-intercepts you're going to have. Okay? Because you're going to be solving it. So like if it's 3x plus 2, you're only going to have 1. If it's 4x squared minus 7, you're going to have 2. Okay? If it's a cubic, you're going to have 3. Because remember, the degree of a polynomial tells you how many solutions you're going to have. Okay? So the x-intercept then is going to be also point or points, and it's going to be some number, comma 0. Okay? So those are the first 4 steps. Now you should have 4 steps on your note sheet. Okay? Those are the first 4. We're going to skip some space for step 5, and we're going to skip some space for step 6. Okay? And we're going to go to step 7. And step 7 says that we're just going to flat out find some more points using a t-chart. Really not much to explain. You're going to pick X values, and you're going to plug those values into your function, and you're going to just get out the Y values, the value of the function at that X. Okay? The only thing that I would add here is you are going to want at least 2 points in each zone. And I'll show you what a zone is in the first example. This one's kind of it's more of a show than just a tell. I just got to show you what I mean. So we're gonna start graphing now. I would recommend that you just do all of your work for this problem, or whenever we're going to do a graphing one. That's why I made this special kind of graph paper that's got space for you to do work right on it. Okay, I would recommend that you just do that right there. Okay. So my first graph, without a calculator, we are going to graph this, and then at the end, we're going to state the asymptotal and end behavior. And it's going to be super duper easy because you're not even going to have to think about end and asymptotal behavior anymore. You're just going to read it right off of your graph. Okay? So our first function is f of x equals 2x divided by x plus 1. Okay? So start on our sheet. We start at the top at step 1. What does step 1 tell us to do? Find the domain. Okay? So what is the domain of this function? More than just -1, because -1 is just a number. And x cannot equal -1. Okay, yep. Because what you did in your brain is you said x plus 1 equals 0, so x has to be -1. So the domain is all real numbers, but x cannot equal -1. Okay? What is the second part of step number 1? Vertical asymptote. So what would the vertical asymptote be then for this function? X equals -1. Now that is a vertical line. Vertical asymptote is a vertical line. So we need to put that on our graph, and we're going to put that on our graph in dashed form at x equals -1. Gotta be dashed. Don't draw it in solid. I will mark it wrong. Okay? Now, what you could also do is, like, if you don't want to dash it like a normal dash, because sometimes you can't necessarily see it, if you wanted to dash it like this, I would be okay with that too. You know, little side, little like this, come down the line like that. 100% fine with that too. Okay? But it can't be solid. Those dash marks tend to work really well if you've got y equals 0 as your vertical axis, or y equals 0 as your horizontal, or x equals 0 as your, because then you're on the axis. Okay? Step number 2 says what? Horizontal asymptote. What's the degree of the top? 1. Grab a piece of graph paper. Grab a piece of graph paper. Grab a piece of graph paper. Degree of the bottom? 1. So those are the same, right? So my lead coefficient on the top is 2. My lead coefficient on the bottom is 1. So my horizontal asymptote is y equals 2. Again, that is a dashed line horizontally 2 up above the x-axis. Step 3, that's new today, right? Step 3 was find the y-intercept. How do I find the y-intercept? Plug in 0, okay? So I'm going to plug in 0. I'm going to find f of 0. That's going to be 2 times 0 over 0 plus 1. Well, 2 times 0 is 0. 0 plus 1 is 1. So 0 divided by 1 is 0. So my y-intercept is 0, comma 0. Step number 4 was find the x-intercept. How do I find the x-intercept again? Set the numerator equal to 0. 2x equals 0. So that just becomes x equals 0. So that also is the origin, 0, comma 0. Okay. Now, I had said earlier step 7, because we can skip down to step 7 now. We'll get 5 and 6 next week. We can skip down to step 7. Step 7 says find some more points, because we only have 1 point that's on our function right now. Okay? So we need 2 in every zone, and I consider zones to be divided up by vertical asymptotes. So I've got a left zone and a right zone. So I need 2 in every space. So I'm just going to make a quick T-chart over here. I'm going to go, let's go with -2. And let's go with -10. If I plug -2 into my function, I've got -2 times 2 is -4, divided by -2 plus 1 is -1. So that gets me 4. If I plug in -10, I get -20 over -9. Now, -20 divided by -9 is just a little bit more than +2. Right? So I'm up here. Grab yourself a graph paper. Then over here, I would need another point in this zone. So I'm going to say like something like +10. 2 times 10 is 20. 10 plus 1 is 11. 20 divided by 11 is just a little bit less than 2. That's what 10 is. 2 divided by 11 is like 1.9-ish, something in there. So we're there. Okay. Now we can draw in our function. Remember, our function cannot cross the blue line. So it's got to make a turn. That's why we pick multiple points. You need 2 points in each zone. Yeah. So that's why I always, and what I normally do is I'll make my T-chart like right in the zone that I'm talking Okay? So that's our graph. Now, here's the cool thing. We don't have to think anymore about end and asymptote behavior. Which one you want to do first? You want to do end first or asymptote first? Asymptote behavior. So that's right here. As x approaches, my vertical asymptote was -1 from the left. Where's my function going? Positive infinity. The other one would be down here. As x approaches -1 from the right, where's my function going? As it gets closer and closer and closer to the blue line on the right side, where's my function going? Negative infinity. There's your two asymptotal behaviors. Over here would be my end behavior. It's approaching 2 from above or below. Over here. Am I above the red line or am I below the red line? Above the red line. Over here, as x approaches positive infinity, my function is approaching 2 from below. Questions, comments, concerns, clarifications? All right. Can we do it? Not really? Well, you're gonna have to do it. Go for it. I'll give you 5 minutes and then I'll start out. So, according to our cheat sheet, or supplemental note sheet, whatever you want to call it, okay, step number 1 says we got to find the domain. So I have to set the denominator equal to 0, and I can factor that. Or I could make it be that, and then I can take the square root of both sides. Either way, I'm going to get x equals 2 and x equals -2. Okay? You forgot the plus or minus. Okay? So my domain here is going to be all real numbers, but x cannot be plus or minus 2, which means my vertical asymptotes, remember I got to write those out separately. Because they're two different lines. Okay? So I put those on my graph. Like that. 2 of them, vertical. Next off, I've got my horizontal asymptote. Degree of the top is 2. Degree of the bottom is 2. Those are the same. So I look at lead coefficient. Lead coefficient up top is -2. Lead coefficient on the bottom is 1. So y equals -2 is my horizontal asymptote. Oops. Okay. Then I find my y-intercept. Plug in 0. If I plug in 0 on the top, I get 0. If I plug in 0 on the bottom, I get -4. 0 divided by -4 is 0. So it goes through the origin. X-intercept, I would plug in now, from what I remember in Algebra 2, we don't have our phones out. From what I remember in Algebra 2 is that because this is a double root, that's going to be a bouncer or a kiss. It's going to come up and it's going to kiss, so it's not going to cross over that. I'm either going to have a parabola in that middle zone, or I'm going to have a parabola opening up or a parabola opening down. Okay? So those rules still hold. Okay? So we can, let's figure out, actually let's make it easier on ourselves. Let's put in positive 1 into it. 1 squared is 1, times -2 is -2. 1 squared is 1, minus 4 is -3. So -2 divided by -3 is 2/3. So that's going to be right there. And then because it's going to be the same, it's going to bounce like this. If you didn't know that it was a bouncer, you could always plug in -1 in that middle zone. Okay. Then we come over here into this zone. Oops, wrong color. Into this zone. So we had 2, so I would go -3 and -10. If I plug in -3, -3 squared is 9, times -2 is -18. -3 squared is 9, minus 4 is 5. -18 divided by 5 is -3 point whatever. 3 point whatever, so it's going to be right there. -10 squared is going to be, that's going to be -200 at the top. 96 at the bottom. That's going to be close to -2, but not quite. A little bit smaller. So this zone comes in there. And I got to go over here. +3 would be -18 over 5. +10 would be -20 or -200 over 96. So there's our graph. Pause for questions before I go to end and asymptote behavior. Yes. Yep. We got to graph the whole thing, because that is this function, or that's the picture So then I'll do end behavior first. As x goes to positive infinity, my function is approaching what? So right side of my graph, where's my function approaching? Right side? -2. Nope, that would be on top. -2 minus. -2 from below. As x is approaching negative infinity, my function is approaching -2 from below again, yeah? Now we'll do asymptote behavior. As x is approaching -2 from the left, where's my function going? As it's approaching -2 from the right, where's my function going? As it's approaching +2 from the left, where's my function going? And from the right, where's my function going? All right. So let's go left to right. As I'm approaching -2 from the left, where's it going? Down. So that's negative infinity. As I'm approaching -2 from the right, where's my function going? Up, going to positive. As I'm approaching +2 from the left, up, and +2 from the right. Much easier with the graph, if you ask me. Okay. Couple of things to wrap up today. So you can do the graph now on purplish worksheet for this week. Okay? You now have enough information to do that graph. Tomorrow we'll have a formative assessment. And that purplish worksheet will be due tomorrow in class. Okay? Yes, the answer is yes. You can use your supplemental note sheet tomorrow on the formative. Yeah. That's why I said that you're going to use this for the rest of the year, the rest of the semester. What I meant by that was you can use that on everything the rest of the semester. I might not have been clear when I said the rest of the semester. And everything.